Thank you so much for having me. Thanks for the invitation. This is actually my first time in Serbia, so I enjoy this quite a lot. My name is Eberhard. I'm from InnoQ. We are a software development company in Germany and Switzerland, about 150 people. Most of my colleagues do a lot of project work while I'm a fellow, so I do more consulting, training, and these kinds of things. I'm on Twitter. I do have a homepage, and I've actually written a few books. So I wrote a book about continuous delivery that talks about tools that you can use to make continuous delivery happen. I wrote a book about microservices that talks about the architecture, why you would do it, the concepts of microservices. And there is also a booklet on a very similar level. It's much shorter and it's actually free, so you can download it at the URL given. I will later give you a way to get all the slides if you're interested. And my latest book is about technologies for microservices. And I thought that maybe you want to have a little rebate on it. So here is the rebate. And there is also, again, a booklet that talks about technologies and is, again, free. So what I want to talk about is software development, why software development is hard, and about complexity and what we can do to fight it, and also why, well, maybe we are actually not really fighting it. Maybe it is something that is that we do welcome. So why is software development hard? Well, when I started software development, I did it with BASIC. So this is a very simple BASIC program. And if you look at it, this is really, really easy. It's just a few lines of code and everybody more or less knows what is going on. So if you have a small program like this, or if you have 100 lines or so then it's not really that much of an issue, and you just have to understand BASIC or assembler or whatever the language of your choice is. I would argue that the real problem that we have is actually complexity. So we are building really huge systems. Some of them are probably the most complex systems that we as humankind ever built. So the core question of software engineering to me is, how can we handle such complex systems? And I would argue that the main thing, the main way of handling complexity is to have modules and to have an architecture. So this is the way how we usually handle this. So what we do is we have our program and we separate that program into independent modules. And each of these modules that we have contain one aspect of the whole system. So that's the idea. So instead of understanding the whole system and dealing with the whole system, we are actually dealing with a module at a time and trying to do that. So the reason why we do this is because now there are two things that we need to figure out. First of all, we need to understand how our system is split into modules. So we need to have some kind of overview about the system, and then we have all the modules, how they interact with one another. And if we really want to do something, if we want to develop another feature or fix a bug, we probably just need to understand one module in isolation. So we can think about that part of the system and we don't really care about the rest, and we can ideally modify such a module in isolation. So that's the core concept. So instead of solving the whole problem at once, we just solve very small problems step by step, and we understand modules in isolation. And the best expression that I have for that, or that I found, is that a module is something that actually fits in my head. So it's not as large as the whole system, it is something that fits in my head, and instead of my head exploding because of all the complexity, I just have to deal with one module, so I don't care about all of the system. And what this enables us to do is we can just throw more people at the problem. So we can have some people working on it, or probably even, well, a lot more people. And we can build teams, and each member of that team can build one module, can deal with one module, develop that further, and so on and so on. So I would argue that the main problem that we have is complexity. And the typical challenge that we have is that we build software in teams because, not necessarily because it's fun to work in teams, but because there is just no way that we can understand and build a system all by ourselves, if it's not a trivial system. So why is software complex at all? I mean, I would have that one module, and understanding that one module by definition should be easy, and it should be easily independently modifiable. And if I have a lot of modules, that doesn't really change anything, because I can still look at one module, modify that, change it, and deploy a different version. And the system is still not really complex, because in reality it's just a set of modules and I just need to understand each of them. So I would argue that the reason why this becomes complex is because there are so many dependencies between those modules oftentimes, and it's hard to figure that out. And if we have a system like this, where there is no apparent high-level structure, where there are so many dependencies, it is something that we don't really want to deal with, and it's a very complex system, hard to understand, and we rather want to run away from it. So as a developer, I would argue this is a very bad thing. We have a very bad project. This is a project that I don't want to work on, because complexity really makes us suffer. It is hard to understand the system. It is hard to change anything. It is hard to figure out what is going on. And you know, you will spend a whole day trying to change a small detail in your system, and you will finally figure out that this really didn't work at all. So I would argue that one of the main things that we should do is we should fight complexity. We should make clear that our system shouldn't be complex. We should eliminate complexity. So we should build the simple solution that could possibly work, simple systems that is enjoyable. And if our system is not simple, well, we should refactor it. So we should change the structure in a way that it's easier to figure out what is going on and what it looks like. And there are ways to do that. So for example, there is don't repeat yourself. So if you have a large system, you should have every decision implemented in one module in one place, and you shouldn't have the same thing implemented in multiple modules, because if you have that, if you do repeat yourself and if you make a mistake, you will have to fix that bug in several places. So that's not enjoyable. And the best thing that you could ever do is actually delete code and make your system smaller and easier to understand. So this is complexity. It's our main enemy that we have in software development. So you would argue that obviously we need to change that, and we need to handle the complexity. Also, what I've just shown is that there is a relation between the people that work on a project and the modules. So the main challenge that we probably have is we have a lot of people working on a project, and I want to dive a little bit deeper into this, because actually the architecture and the people are strongly related, and that is what Conway's law says. So Conway's law says the architecture of a system that you have copies the communication structure of the organization that is building the system. So that's the idea. That's what the law says. And this basically means that if you have the organization and the architecture drives the architecture drives the organization. It's really the same thing. So that's what it's all about. And to make that a little bit more clearer, I want to talk about how the organization drives the architecture first. So there are two things here. Organization drives architecture, architecture drives organization. So let's talk about how the organization drives the architecture. So let's imagine that I have a few teams, and I have teams talking to one another. And this is my setup in my project. What will most likely happen is that those teams will build separate modules, because if they build separate modules, they don't have to communicate that much, because it's really separate things that can be separately implemented. And you know, that is the reason why we have teams. They should work together on a piece. So a module is ideal for that. And then we would negotiate interfaces between the teams. So I would go to the other team and say, well, you know, we are working together, so here is an interface. This is how we are going to do that. So probably my architecture will look like this. So if I set up an organization, I will actually probably with a specific architecture. And this is also true the other way around. So if I have an architecture, it will probably drive an organization. So I have a few modules that somehow depend on one another, and now I want to somehow make several people working on this project. So what I will most likely do is I will take the modules and give them to some teams, and they will talk to one another now to fix the interfaces and to make sure that it all works together. And this gives rise to quite a few interesting things. So the organization actually becomes a tool for architecture. So if I have a team structure like this, I can basically say, okay, guys, you're responsible for doing the order processing, and you can give requirements to the other team. They are doing the shipping, and then we have the invoicing, that's the third team, and we will have meetings between order processing and shipping, where order processing gives requirements to shipping, and shipping and invoicing. And because of that, you have given the priority to order processing because they can steer the shipping team and can tell them what to do. Well, and once you've set up this organization, it's basically all you need to do to come up with an architecture, because what will happen is you will have this kind of architecture, so you will have three different modules, and the priority will be on order processing. So if you actually set the priority to order processing just by doing an organizational decision, which is that the team responsible for order processing can give requirements to the other team. So I would argue the organization that you have in your system to build your system, that must be defined. You have to set up the teams, you have to define how the teams should interact, and that is the most coarse-grained architecture that you can come up with. So if I have a team, I'm actually in a large team, or maybe also just a few persons working on something, I'm actually quite interested in this level because it's the most coarse-grained architecture, and it's so very important. The rest just results out of that architecture approach. And the idea to use the organization as a tool for architecture is something that is more or less commonplace nowadays. So domain-driven design talks a lot about it, how you can set the priorities, how you can make teams interact with one another. And it's also something that microservices care deeply about, because they say that each microservice should be handled by one team. And microservices also enable, well, more independent teams, better organization. So, as I said, the organization must be defined, and all of this has been done by Mel Conway. He is still around, he's on Twitter, so you can just follow him. I had the pleasure to hear him talk last year, so he is still around and he is still doing his thing. And also you can download the original paper that discusses Conway's law. And as you can see here by the portrait of Mel Conway, this is actually quite an old paper. And I want to dive a little bit deeper into this. It's quite enjoyable to read the original papers and to see what they are talking about, because actually this paper talks about complexity, and it also talks about, well, managers. So let's talk about what Conway's paper says and what you probably haven't heard about. So we have a lot of people in our project, and because of that we have a lot of modules in our project, and this is our project. And we would set up communication infrastructure, and we get started, and now we add the manager to the equation. This is something that Conway talks about in his paper. So he says, well, the manager has some prestige, and the prestige depends on the size of the team. If I say I'm a manager and I'm managing 3 people, well, that's not really impressive. If I manage 10 people, that's somewhat impressive. If I manage 100 people, that's great. So I'm obviously a very good manager. And the same is true for the budget. If I just have 100,000 euros each year, that's more or less a joke. If I have 10 million euros each year that I care about, that's a really fantastic manager. So this means that the size of the team and the size of the budget is important for the prestige, but it's also important because as a manager I can say, well, you know, this project didn't really work out, even though 100 people were working on it. So it's really a hard problem. So I rather have 100 people working on it, because then I can say, well, here's the excuse. It's a really tough problem. So I would argue I will probably strive for a large team. I would try to get a large budget, and even for a small project. So I will try to get as many people working in my project and as many people working, as much money as I can possibly get, because that's more prestigious, and this is what I'm incentivized by. So instead of having a small team like this, well, it's actually not a small team, but instead of having this team, I can maybe quadruple the number of people working on it, and then I have a large team. Now you could argue, well, who cares? I mean, as a developer, I'm a member of that team, and I will be like, okay, so I have 100 people working on this project. Really, the project should just be enough for 20 people, but it's just a matter of budget. So someone is spending a lot of money here, but I don't really care. The additional people will just do nothing, so why would I bother? And probably you should care, because there's an interesting thing going on in the world. And I want to talk to you about the original scenario that well, made this quite apparent. So there is the colonial office of the British Empire. Obviously, it's not there anymore. So the British Empire was really huge. It had a lot of colonies, and you know, because of the independence, because for example, of the United States or of India, the number of colonies declined over time. So it were less and less colonies over time. So you would believe that, you know, there was less work, so there should be less people working in the colonial office, but it turns out that this is not true. Instead, the number of employees actually rose, and when there were no colonies left, more or less, then the number of employees was actually the maximum. So when it was dismissed, that is the time when there were the most people working on in this office. And that's weird, right? I mean, you would believe that it should shrink in size, there should be less people working, but that's not what's happening. So why would that happen? So the reason is, first of all, if I'm working in that office, I probably want to have subordinates, people reporting into me. It's the same thing as with managers. I want to have people reporting into me, and I don't want to have rivals. I don't want to have people on the same hierarchy level as me. I want to have people reporting into me. People on the same hierarchy level as me are competing against me for their career, so that's not something that I would enjoy. And you know, once I have this organization set up, I will probably create, they will probably create work for one another. That's sort of a golden rule about bureaucracy. So I come up with new rules, I come up with new laws, and all of these new rules and new laws will somehow make sure that the other parts of my organization also have to do something, and you know, that is how we create more work, and everyone is actually busy. And it turns out in organizations like these, where there is an office that does stuff, the number of employees typically rises by 5 or 7% per year, and that doesn't depend on the amount of work that is being done there, if there is any work at all. So there is a study, I believe, about the Naval Office of the US Navy, and they had these kinds of numbers, and there was no better throughput. It was just more people working on it. And this is something that is called Parkinson's law. So Parkinson's law states the work that you have expands, and it fills up the time of all people available for its completion. So if you have some piece of work, then all of the people will be busy working on it if they are available for the task. And this is what Conway says in his original paper. So the manager starts off building a huge organization, and you would believe that, well, some people will just sit around and do nothing, but that's not the case, because Parkinson's law says everyone will be working on the problem and on the project, so we will actually have all of these people busy working on the project. So now we have a large organization. Now everyone working on the actual problem. And the problem that we have now is, how do you do communication in such a large group of people? And it turns out that this is hard, because if you have everyone talking to everyone, then you have sort of chaos, and you will probably have a fail where communication breaks down and it's really, really hard. And then there is Conway's Law, and Conway's Law says that your organization is pretty much like the architecture, so probably your architecture is also complex, and then you are in a complete disaster, so to say. So you have a large project, you have a lot of people working on it, you have a very unclear architecture, and you end up with a large project that doesn't really work, and where the structure is really, really bad. So it all starts with the manager who cares about his or her prestige, builds up a large team. Now Parkinson's Law says, well, all members of that team will do some work, and that will make communication hard, will make communication fail. This is where Conway's Law comes in and says the architecture will be complex, and you have a problem. And what I think is so I'm not sure whether anyone has experienced something like that. What I find interesting about this is that it's from Conway's Law, and it's from 1968, so it's about 50 years old, so we should be pretty aware of the problem, and we should actually fight it. And the other thing that I find interesting about this is it basically means that large projects are not just costly and are not just risky because they are large, so there is a lot of money being spent on it. It also means that they have a higher tendency to have a bad architecture, even though they probably shouldn't, because in a large project, architecture is very important. And that is what Parkinson and Conway explain, what those two laws explain. So this is where we have a problem. So I would argue, if you sum it up on one slide, that probably managers worship complexity. It's not like they go to the office on Monday morning and say, yeah, we should build a complex system. It's rather that they say, well, I really want to have a large system, a large group of people working on it. I really want to have a large budget. And what the result of this is that they build a system that is much too large, much too complex, and has a high risk to have a really bad architecture. And that is the problem here. So I don't think that they do this voluntarily. It's rather something that happens to them. Now you could argue that, well, we are developers. So as a developer, we probably don't worship complexity, because we are the ones who are actually doing the work on the ground, and we are the ones who are really suffering. So why would I worship complexity? It is something that makes me suffer. So let's talk about it's obviously the manager's fault again. So let's talk about developers and complexity. So let's imagine that I would be standing here and I would say, well, you know what? I developed a new system, and it's just a very simple Java application. And you would be like, I don't care. I mean, why are you even telling me that story, right? Java has been around for 20 years, so what's the great deal about it? Well, it actually made a lot of money to my customer, but that really doesn't change your opinion. It's a simple system, it's a very successful system from a business perspective, but probably you're not impressed. While if I stand here and say, well, I did a microservices system, and I'm using CQRS, which is a great technique to have reading and the write part of your system, the one that is responsible for reading, the part that is responsible for writing, to separate that, to make it individually scalable. And I use event sourcing, so I put all the events somewhere, and I can regenerate the state of my system from those events. And I'm using Kafka, which is a very nice modern messaging system, and I use Kubernetes, which is a very nice system to run your microservices on, and it's really, really a great system. And I even use the Istio Service Mesh, which is a recent development that also helps to build microservices systems. You would be like, oh, wow, this is actually quite interesting. Why don't you do a conference talk about it? Because it's really, really interesting, the kind of technologies that you're doing, using the complexity of that system, all these great modern things. but you know, maybe I didn't generate any business value, and you would be like, I don't necessarily care. And other cases, so oftentimes I go to customers and they say, well, we built a highly scalable system. And we do some technologies for that. So we use NoSQL databases or we use a cloud. And I think in a way, they actually enjoy that quite a lot. And probably people are like, wow, this is really interesting. But what I found fascinating about that is that oftentimes they don't really have a lot of users, and they should probably care about how to get these users first before they build that scalable system. But still, it is something that is enjoyable, so we solved a lot of technical problems. And when I was preparing this talk, I found an interesting tweet. And this tweet says, developers actually expect complexity. So if you give a simple project to some developer, it will first of all make the project complicated so that it's actually fulfilling and interesting. And if there is no problem, they will somehow create one. So I found that quite interesting. And I would say this is not really surprising at all. So what I was talking about in this presentation is that actually it's the business people that care about business value. That is why they are business people, right? They care about how much money we are making, whether we are solving the real problem, whether we have users, and these kinds of things. But as an engineer, I don't really care about business value that much. That definitely includes me. I'm an engineer because I love engineering, right? That's obviously why I chose this job. I didn't choose this job to make some system that is hugely successful with users. I want to build a system that is interesting from an engineering perspective. And if you build a complex system, that's obviously more challenging and probably more fun than a simple system. And also it provides more prestige. So if I say, well, you know what? I've built this really huge system with all these modern technology and it's hugely scalable, you'll be much more impressed than when I say I built this really small system that solves some business problem. And I have to admit that there is a specific project where we built such a great scalable system. We hardly had any users. That was not just fun, it was also something where I actually learned a lot. So I would argue that developers actually worship complexity too for very similar reasons. Also because of prestige and because of the way that that our society sort of works. Now, developers worship complexity, managers worship complexity, but I would argue that there is more to the story than just worshipping. And to explain that in a little bit more detail, I want to talk about a consulting gig that I did once. It's actually more like a pre-sales meeting. So we were sitting there and I was talking about how continuous delivery is a great thing, how you can continuously deploy software into production and how this is a great thing and how you could use the cloud to make this really easy and to save a lot of money. And the response from the potential client was, that won't work here. And I was like, well, you know, it works at Google and Amazon and at some of my customers, so why wouldn't it work here? Well, maybe it works at those organizations, and I don't really doubt that. If you look at the statistics and if at the publications, it's obvious that it works at Google and Amazon. But our system is much more complex. So this is quite an interesting statement, and when I prepared the presentation, I wanted to get an idea about how complex Google is. So Google has about 2 billion lines of code. Now you could argue that 2 lines of code is not a good measure for complexity, but I guess we can all agree that this is quite a huge system and probably none of us has ever touched a system of that size. They have 25,000 engineers. That's probably more people working on that system or at Google than I had at this customer. And they have 2.5 million servers. So by any measure, this is actually a system that is truly complex. And at one point, I tweeted about how this is very weird and how I cannot make any sense out of it. And I believe that now you could argue that that customer is just being stupid. I don't like the idea that people are stupid. I think they aren't. So what's a good explanation for that? I think the explanation might be the complexity, something that I call the complexity fallacy. So if I look at a system from far away, if I look at Google, I mean, searching, right? How hard can it be? There is just a search engine. So, and that's more or less commodity. So why would I bother? And by the way, it turns out I'm using DuckDuckGo these days. They have a search engine too. They have about 50 people working on it, so it can't be that hard. So from far away, everything is easy, even if you look at Google or Amazon. It's just that we don't really appreciate the details and how this stuff is complex. So I assume it's complex because you want to fight search engine optimization. I assume it's complex because of the data size, because of requirements concerning the time that it should take to answer requests, all these kinds of things. So the main problem is that I don't really know that you don't really know other systems, so it all just appears easy. And that is something that happens to me too. So I'm doing consulting, so oftentimes I go to some customer and they tell me about their business case and I'm like, yeah, that doesn't sound too hard. And then after an hour, you understand how this is really, really hard to do it. This also works the other way around. So if I look at the details of the system that I'm working on in an insurance company, in a bank or so, then it is truly complex. And the reason why I believe that is because I know my system quite well, so only to me it appears complex, even if I compare it to Google, where I don't really know what's going on, so I assume it's easy. So this is one thing. So I have the assumption that what I work on is actually quite complex, while everybody else is working on really, really simple systems, and that is something that I believe you have to be aware of. Now, there is another thing here, and that is that complexity is a great excuse. So if I say my system is so complex that I can't do continuous delivery, that I can't do cloud, the end result is that, well, I don't need to care about it. So it's actually something that is that makes my life easier. I don't need to involve myself. I don't need to read the books about it. I don't need to get it done because it won't work in my environment anyway because my system is much too complex. So in conclusion, what I am trying to say here is that first of all, managers do worship complexity. The reason why they do it is because of prestige. That's the main reason. I'm not sure that they do it openly or even voluntarily or that they even know about it. It's just something that is the result of the way that they behave, but so do we. What we want to do is we want to have interesting engineering problems, and interesting engineering problems are complex. And the driver behind these is, I think, first of all, prestige, but also the excuse to not have to deal with other things and other approaches that might make our life easier. So what's the conclusion? Well, you should avoid complexity. So you should build systems that are simple. You should build the simplest system that could possibly work. And you should probably do a boring job. That's sort of something that I think is actually, I chose the word boring for a reason, because I think that clearly expresses what is going on. It's going to be a system that is easy to develop, but it's also probably going to be boring because it's not that much of an engineering challenge anymore. And in a way, you wouldn't have to care about your prestige then, because you're just working on some boring system that just gets the job done. You will end up with a better, less stressful life because you don't need to care about complexity that much, and you will probably have some business success. So it is something where you can actually maybe also earn quite some money. Or maybe you're actually building a complex system for a very good reason, but it's hard to tell the difference because you will probably say, I know that the system from detail. I know why it's complex. It has to be complex. So it's hard to tell the difference between this case and the case before. So you should be aware of the complexity fallacy and about how you worship complexity. Thanks a lot for listening. Thanks a lot for enjoying the talk. Thanks a lot for having me. I'm going to be here for a few hours. So if there's anything you want to talk to me about, feel free to do so. I would be happy to answer any questions that you might have. Thanks a lot.